Today we're looking at applications of quadratic functions. So there's two different types we're going to look at. The first type says, at last year's school fair, an 18-foot by 15-foot rectangular section of land was roped off with a dunk tank. The length and width of the section need to be increased by x feet this year in order to triple the original area. Write and solve an equation to find the value of x, or the dimensions of the new section. So our original dunk tank area was 15 feet by 18 feet. We want to make a new dunk tank area that we've added x feet to each side. So this will be x plus 15 and x plus 18. But it also says we want to triple the original area. So we know area is length times width. So if we find our original area, we multiply 15 by 18. That would give us 270. If I want to triple that area, so if I take 270 and multiply it by 3, that'll give me the new area I'm looking for, which would be 810, because 270 times 3 is 810. So this is what we're looking at. We're looking at using this equation here to find what x has to be. So what would x have to be so that way my side length x plus 18 and x plus 15 would give me an area of 810. So we're going to set up an equation that will do that for us. So we know that the area of a rectangle is length times width. So my length is x plus 18. My width is x plus 15. And we know that if we multiply those together, we're going to get our area, which we want our area to be 810. So in order to solve this, we have to FOIL it, set it equal to 0, and then factor it again. So we're going back to factoring, but we can't factor when it's set equal to something, so we're going to have to FOIL this out. So we've got x times x, which is x squared, x times 15, which is 15x, 18 times x, which is 18x, and then 18 times 15, which is 270, and that is equal to 810. So now we need to combine like terms. So we have x squared plus 33x plus 270 equals 810. We still need to set it equal to 0. So we're going to subtract 810. So we have x squared plus 33x. When we subtract 810 from 270, then we end up with negative 540. So if we do 270 minus 810, we get negative 540. Now we need to factor this. So we're looking for things that multiply to be negative 540, but add to be 33. Now there's a lot of factors that could be here, so I kind of just start in the middle. Most of these, they're going to vary, but they're not going to typically add 2 or 3 feet to each side. So I'm going to start with 10 on this one. So if I think about 10 times 540, to add to be positive, our 10 would need to be negative. Oops, 10 times 54, not 540. So negative 10 times 54 multiplies to be negative 540, but it adds to be 44. So that's not what we're looking for. So then I go down. I don't know which direction to go, so I'm going to go down. So if I do negative 9, so if I do negative 540 divided by negative 9, that tells me that 9 times 60 is 540. Well, if I add those together, I get 51. That's getting further away from 33, so now I need to look at numbers bigger than 10. So if I go 11, 540 is not going to divide by 11, so now if I look at 12. So 12 times 45 is 540. So since we want to add to be positive, we'll make the 12 negative. So if we look at that, negative 12 plus 45 is 33. So we know these are the factors I'm going to use. So this will factor to be x minus 12 times x plus 45 equals 0. We still need to solve to get what x is. So here we could get x equal to 12, or x would be equal to negative 45. If we think about this problem, if I made x a negative 45, that would make me have negative side lengths. So this x value doesn't make sense in my problem. So we know that x is equal to 12, which is the first thing it asks. It asks the value of x, so we'll add 12 feet to each side. And then we need to find the new dimensions. So if I look at 12 plus 18 and 12 plus 15, then my new dimensions would be 27 feet by 30 feet. And if you multiply those together, you get 810, so you know you have the correct area. The second example we're going to look at says, for a science competition, students must design a container that prevents an egg from breaking when dropped from a height of 50 feet. The height in feet above the ground after t seconds can be modeled by the equation h equals negative 16 t squared plus h naught. H naught, h of 0, that's your starting height. So if you want to add into your notes that this is always the starting height, that'd be a good thing to add. How long does it take the container to hit the ground? So we're going to start with our equation. H equals negative 16 t squared plus h naught. H naught is our starting height, so we know negative 16 t squared. We drop it from 50 feet, so that's the starting height, so plus 50. And we want to know when it hits the ground. So take to hit the ground. When our egg hits the ground, its height is 0. So we're going to plug in 0 for our height. So it's 0 because we hit the ground there, and our h naught is 50 because that's where we dropped it from. So now we need to solve for t. Because we just have a t squared and no other t's, we can solve by square roots. So I'm going to subtract 50. So we have negative 50 equals negative 16 t squared. Now I divide by negative 16 to get t squared by itself. So we get t squared, so that's a t, equals 3.125. Now we take the square root. Now because we're dealing with decimals and time, we give time in actual seconds. So we take the square root of this, we get plus or minus 1.7677, blah, 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 and it keeps on going. Now again, we have to think logically. We can't have negative time, so we're going to use the positive value here. We're going to round this to the tenths, so we'll have 1.8 seconds. So it will take the egg 1.8 seconds to hit the ground. Those are the two types of problems we're going to look at, and we're going to do a few more examples of each of those in class tomorrow.